talking about solving equations, right?
Yeah.
We've been kind of building on it all week. We're going to skip the fluency drill because donuts, remember? And we're going to jump into this partner warm-up. So we've been building all week. Today we're going to build onto the skills we've been working on, and we've got a scenario here. So Tyler, I'm going to ask, this is actually not on paper, it's only on the screen in front of you, so all eyes should be on the screen. Tyler, I'm going to ask you to read this in a loud, clear voice for us.
Sheila, whatever her name is, plans to solve this equation. You need to go find like terms, add 5x and 3x to get 8x.
Beautiful, stop there. Anastasia, second part. Awesome. So we've got two scenarios here. Shayla, who says we need to add 5x and 3x here to solve. Yoselin, who says we need to subtract. Your job is to talk with your partner and determine who you think is right. The person with the larger shoe size is going to talk first. If you need to move because you don't have a partner, that's totally fine. But let's talk with somebody who we think is right. Be ready to share out. Go. First, let's talk about this. So, figure out what I think is I can make an assumption, but I think we're already figure this out. So, what do you think? Either add? Yes. I'm looking at
Avoiding the 13 still, bro.
God.
Yeah, bro.
And you think it's how
well, why do you think? And there's another reason why you think
All right, let's bring it back together, please. Voices are up, eyes are up here in 3, 2. Thanks, Anastasia. 1. Thanks, Justin. Thanks, Brandon. Thanks, Vanessa. Alex and Evelyn. All right. Everyone just talked about this. There's also only 2 options here, so I want everyone to choose one or the other. You're either going to raise your hand because you agree with Shayla or you agree with Yoselin. So, I agree with Shayla. We should add these terms. Raise your hand. I agree with Yoselin. We should subtract these terms. Raise your hand. Woohoo! Okay, CJ, why?
Makes me new not to call it. All right.
Do I like to hear your thoughts?
Because it sounds better. Because if it's on the opposite, I've never seen one that's on the opposite side of it.
I've never seen one that's on the opposite side. Say more. What do you mean?
Meaning, if it's on the opposite side of the equal sign. Then
What's on the opposite side of the equal sign?
the 3x.
Ooh, okay. So CJ's saying that, wait, I don't need to say that for you. So, yes, good. Stamp that for us. Omar, I want you to read that in a loud, clear voice. This is exactly what CJ just said.
When like terms or x terms are both sides of the equal sign, inverse operation must be used to get x terms to the same side of the equal sign.
Beautiful. So let's check our understanding on that one more time with a partner. So you got 2 equations up there, a red one and a blue one. I want you to, this time smaller foot person, you are, nice boots, you are going to decide which one would we use inverse operations for, red or blue. Talk to your table partner, be ready to share out. What was that? Oh, give me a compliment. I like them. I'm looking at everyone's feet because I'm looking at shoes today. Nice boots.
So in here, that's like a subtraction and add.
Okay, we just talked about, did you hear what CJ said?
No.
Okay, he talks about he's never seen X's on both sides of the equal sign. Do you see that in either of these pieces of problems? Which one?
Is it 6 from 3 or is it 6 from 2?
So that's the only reason. Great. All right, y'all, let's bring our attention back together, please. Let's get a check for understanding here. So, again, thanks, CC. Thanks, Charmaine. Again, red and blue. You vote for one of them. If you're not sure, guess, okay? There's no opting out. So raise your hand if you think red is what we would use inverse operations for. Raise your hand if you think the blue equation is what we use inverse operations for. I heard a good explanation from Josh and Jason here. Josh, why is red the correct answer? What did you say when we were discussing? What did you notice about the red one? Yes, X's are on both sides of the equal sign. So when you have X's on both sides of the equal sign, you got to get them all together. And to get them all together, will you grab me a note? You got to use inverse operations because you're crossing that line. So let's take some notes together today so we have some good examples of what this looks like. And that way later, if you're like, oh shoot, I forgot how to do this, you got something to reference, okay? So notes are out. Your paper's going to